Number theory is the branch of mathematics devoted to the study of whole numbers and their properties. Just as understanding the rules is essential before playing a new game, exploring number theory helps us uncover the fundamental principles that govern numbers. This field reveals patterns, relationships, and hidden structures within the numbers we use every day. By delving into number theory, we prepare to discover what makes certain numbers stand out and why they hold a special place in mathematics. Number theory is a branch of mathematics dedicated to the study of whole numbers and their properties. It seeks to answer three fundamental questions: how whole numbers can be divided, how they are related to one another, and what patterns they exhibit. Division explores concepts like factors and divisibility, while connections between numbers include relationships such as primes and composites. Patterns involve recognizing sequences and regularities within the set of whole numbers. Importantly, number theory focuses exclusively on whole numbers, setting it apart from other mathematical disciplines that consider fractions or decimals. Even and odd numbers are two basic types of whole numbers. An even number can be divided by 2 without leaving any remainder like 4, 8, or 12. Odd numbers, on the other hand, leave a remainder of 1 when divided by 2, such as 3, 7, or 15. A simple way to tell them apart is by looking at the last digit. If it's 0, 2, 4, 6, or 8, the number is even. If it's 1, 3, 5, 7, or 9, the number is odd. For example, 26 ends with a 6, so it's even, while 37 ends with a 7, making it odd. Prime numbers are a special group of natural numbers that are greater than 1 and can only be divided evenly by 1 and themselves. This unique property sets them apart from composite numbers, which have additional divisors. Some key examples of prime numbers include 2, 3, 5, 7, 11, and 13. Notably, 2 is the only even prime number because every other even number can be divided by 2, making them composite. Additionally, the number 1 is not considered prime, as it only has a single positive divisor, rather than the required 2 distinct divisors. Composite numbers are whole numbers greater than 1 that can be divided evenly by numbers other than just 1 and themselves. For example, the number 6 is composite because it can be divided by 1, 2, 3, and 6. Similarly, 12 is composite since it has several divisors, including 1, 2, 3, 4, 6, and 12. In contrast, prime numbers have exactly 2 divisors, 1 and themselves. Every whole number greater than 1 falls into one of these two categories. It is either a prime or a composite number. Factors are numbers that can be multiplied together to produce a larger number. For example, let's look at the number 12. The pairs of factors for 12 are 1 and 12, 2 and 6, and 3 and 4, since 1 times 12, 2 times 6, and 3 times 4 all equal 12. This means you can arrange 12 objects into groups of these sizes without any leftovers. Understanding factors helps us see how numbers can be divided into equal groups in different ways. Multiples are the results you get when you skip count by a specific number. For example, if we use 6, we start at 6 and keep adding 6 each time. The sequence goes 6, 12, 18, 24, and so on. Each new number is found by adding 6 to the previous one. This pattern of multiples continues without end, creating an infinite list of numbers that are all divisible by 6. The greatest common factor, or GCF, is the largest number that can evenly divide two given numbers. To find the GCF of 12 and 18, we first list the factors of each number. 12 has factors of 1, 2, 3, 4, 6, and 12, while 18's factors are 1, 2, 3, 6, 9, and 18. The largest factor they share is 6. Therefore, the GCF of 12 and 18 is 6. The least common multiple, or LCM, is the smallest number that can be evenly divided by both of the given numbers. To find the LCM of 4 and 6, we start by listing the multiples of each. The multiples of 4 are 4, 8, 12, 16, and so on, while the multiples of 6 are 6, 12, 18, 24, and so forth. The first number that appears in both lists is 12. Therefore, 12 is the least common multiple of 4 and 6. Number theory plays a significant role in our everyday lives, even if we don't always notice it. By studying number theory, we learn how to recognize patterns within numbers, which is a skill that helps us solve a variety of mathematical problems. This foundation is crucial when we move on to more advanced topics, such as fractions and algebra, where understanding the properties of numbers becomes even more important. Through number theory, we develop logical thinking and problem-solving abilities that are valuable in both academics and real-world situations. Now that you've explored the concepts of prime numbers, factors, multiples, greatest common factor, and least common multiple, it's time to put your knowledge to the test. Try identifying which numbers are prime and which are not. Practice finding all the factors and multiples of a given number. Challenge yourself to calculate the greatest common factor and least common multiple for different pairs of numbers. Applying these skills will help reinforce your understanding and build confidence in working with numbers. In summary, number theory reveals the fascinating structures and relationships hidden within the world of numbers. By exploring patterns, divisibility, and the properties of primes, we gain a deeper understanding of how numbers behave. Rather than being mysterious, numbers follow consistent rules that can be uncovered through careful study. Embracing these patterns helps demystify mathematics, making it more approachable and engaging for everyone.